In this video series, I'm going to show you how to create the 3D solid model of the bearing part shown in your Giseki text. And when I get done with the part construction, I'll show you how to create the detail sheet for the part. Now, the first thing I want to point out is the orientation of the part here that I've already drawn. Okay, we want to create our part in Inventor where the orientation of the part is as shown in the text. Okay, for consistency. Now, my view is similar to what's shown in the text. When I say similar, this is an isometric view. Okay, which we've discussed in other classes. The view shown in the text is actually a cabinet sketch, but for all purposes, the orientation is the same. In other words, the front view shown in the text is the same as the front view I have here, which matches the front plane shown on the navigation cube. Okay, so this is the way that we want our part to end up when we finish our part construction. By the way, my part is yellow here just for contrast for the video. Do not create your part as yellow. I do this because this shows up well. Okay, so we'll go ahead and proceed with the part construction. So I want to start a new part. And how do we know whether to use English or metric? Okay, well, the two things that are readily apparent in the text that is an English drawing is that you don't see the word metric enclosed in a rectangle, which you should see if it's a metric drawing. Or we also don't see the dimensions given in millimeters, nor do we see in the directions for the part in the text. We don't see it saying construct the part in metric. Okay, so this is an English part or a part dimensioned in inches. Okay, so we want to use a standard inch.ipt part file. So I'll double click on that, and then we go directly into Inventor. Now, it's possible here, I don't want to get on a big tangent, but it's possible that you were ushered directly into a sketch on the front plane. That was a one-time setting in Inventor, and you may see that. If you do, we actually need to start off on the right side plane. So if you don't see a grid here, just hang on a minute. I'm going to demonstrate something, but you don't need to do anything. If you do see a grid, you may want to follow along. But I'm going to recreate that situation. So now here's the grid that you may have seen when you first started Inventor. If you did see this, just click Finish Sketch, and then we want to actually delete that sketch. Okay, so now we're back where we started. And we all want to create a sketch on the right plane. Okay, so select create sketch, and we want to create it on the right plane, which is here. Okay, now you notice when I clicked on the right plane that my navigation cube rotated. Yours may or may not do the same. If it did, just simply use these curved arrows at the top to rotate it where the word right is actually right side up. Okay. Okay, so now we're in our grid here, and we need to create our object. Now, the reason I wanted to sketch on the right plane, let me go back to my part that's already made, is because I actually want to take advantage of the Revolve Command in Inventor, which is very handy for round parts like this. Now this part's fairly simple, and you could have created it with a couple of extrusions. But I wanted to familiarize you with the Revolve because the Revolve Command can actually be a much handier option on more complex parts. So notice that the YZ plane, or the right plane, notice the orientation of the red window there, the red plane that you see is the same as the right side of the navigation cube. We'll actually want to create a L-shape sketch on this YZ plane and then revolve it around 360 degrees. Very handy for a round part. So that's what we want to do. So I'm just going to start off, and I'm just this is the center point of my drawing. Okay, the object has a hole. Okay, so we don't want to start off sketching right here at the center point. We actually want to kind of sketch above it. Okay, and I'm just going to kind of come out here to the right a little bit, above and to the right of the center point, and I'm going to draw a line straight up, straight to the right, straight up, straight to the right, down. Okay, now be careful when you go to close this. You want this line to where you're able to create straight horizontal, straight vertical lines. Okay, all these should be straight, either vertical or horizontal. Okay, so make sure that you do that first and accurately. All right, so this is our rough sketch, and there are several dimensions that need to be applied to this sketch. Your goal is to actually, down here right now it says I need 6 dimensions, but we want that to say fully constrained. In other words, it doesn't need any dimensions. All right. So one thing I want to do is to actually just place this sketch, and you can do that through constraints, and I also want to dimension the sketch. I'm going to start off dimensioning the sketch, and one way I'm going to dimension it is, notice that I said that we were going to revolve the L shape around the center of the part. Okay, one way that I can do that easily is I want to use the Project Geometry tool in Inventor. And what the Project Geometry tool allows me to do is to project existing geometry onto the current sketch plane. Not only existing geometry, you can use these entities, these standard entities that are in the origin folder on the model tree. Okay, so if I click the plus button next to the origin folder, I'm already in the Project Geometry. Let me click on the Z-axis. Okay, now you can see the Z-axis highlight here on my screen. But when I click on the Z-axis, I have a new line that's green. Okay, so it basically took, you can think of it as maybe a shadow or something, but it projected the Z-axis onto the current sketch plane. And what that allows me to do is it allows me to use that line for dimensioning. Okay, this will make more sense the further we get along here. So let's go ahead and start dimensioning the object. Now the outside diameter of the object is 5.5. Okay, so let me use the general dimension tool here, and I want to first click on the line that I just projected, and then click on this line, and I want to pull it out to the left. Now you can see that I have a linear dimension, which I could use, but there's a better way to do it. Before I actually place the dimension, okay, let me right click and select linear diameter. And now I can place the dimension. And what that does is I can actually type in the dimension as shown in the text. Very handy. And plus, later on I'll show you how we can bring these dimensions into the detail sheet. So that's a good way to do it. Again, let me use the general dimension tool. I'll click on this line. Now let me click on this line. Again, before I place it, let me right click, select linear diameter, and now I'll left click to place the dimension. Let's do that once again. And I'll do it for this dimension. Right click, linear diameter. Okay. So now that I've done that, I can go back and adjust these dimensions. Okay. So this dimension, let me actually start off with the the larger dimension here. Let me double click on that, and then I'll change whatever number happens to be there to 5.5. Okay, you can see it updates my sketch. I'll do the same for this one. Okay, and then I will do the same for this one. Now you'll notice in the text that we're given a limit dimension. Okay, just for now, choose either the lower number or the upper number. So I'll choose 1.5 and then enter. Okay. Now let me go back and edit that again. Let me double click on that and click on this arrow and then go to tolerance. Okay. Now this allows me to apply the tolerances in the sketch. So let me use this drop down box, and I will go down and select limits linear, because this is a limits linear dimension that we're given in the text. The upper dimension is correct. It's 1.5. The lower dimension needs to be changed to 1.498. And then select OK. And then the green checkbox. Okay. Now you can see the limit dimension just as it's shown in the text. So let's keep applying dimensions. Okay, we need a dimension here. I'll pull that up here.